Avogadro's number in the mole section 3.4, mole, a four-letter word that tends to give our students a lot of trouble. Now, the idea of a mole is not bad. When we say a dozen, immediately in your mind comes to the 12 objects, 12 eggs, maybe 12 elephants. There's no problem with that. What you need to know about that dozen is they have the same number, but they have different masses. So one of the first things to pick up about a mole is more than 12. A mole is 6.02 times 10 to the 23rd objects. If I call my objects oxygen, water, and sodium chloride, oxygen, a mole weighs 32 grams. For water, a mole weighs only 18 grams. And for sodium chloride, a mole weighs 58 grams. So just like a dozen, where eggs and elephants have different masses, so do objects when we talk about moles. And there in the right-hand corner is my idea at a bad joke. All right, 1 mole is defined as the number of atoms in 12 grams of carbon-12. So if I take those 12 grams of carbon-12 and I know the mass of 1 carbon atom, I come up with the number 6.02 times 10 to the 23rd carbon-12s. That is where Avogadro's number comes from. So you see I have written here 1 mole is that number of objects. Notice each of these on the left-hand side says mole. Each of these on the right-hand side says 6.02 times 10 to the 23rd. And all I've done is change from atoms to ions to molecules. So you may have a word question and it'll help you. They want you to understand, what does this mean? What I want to do is give you some practice using Avogadro's number. I have 6 problems, and we once spent 4 hours in a summer course with incoming college students working through this. It's easy, but it's also hard. It depends on where you're coming from. So it says, how many moles of copper are in 3 grams of copper, which is an old penny? What conversion factor do I need? I need to know that 1 mole of copper has a mass of 63.55 grams. As long as I know that, I'm going to use dimension analysis from chapter 1. 3.00 grams of copper, and I will say 1 mole of copper, it weighs 63.55 grams of copper. Now, you know, I've told you I earned a C when I took Gen Chem. I never put labels on anything. It was like below me. You know, it's just like, I'm not going to do that. But when I started to teach, I thought, wow, if you have the labels, you can see how they cross each other out. And it is the dimension analysis from back in chapter 1. So when I put the numbers into my calculator, I get 1.005 times 10 to the minus 22 grams for every copper atom. Now, I'll be honest, often students just can't comprehend what this means, and that means you're normal. In time, with practice, it all starts to make sense. I'll add in here 2 significant figures, so what I must have are 2 significant figures in my answer. That's problem number 1. Problem number 2 says, take atoms and turn them into grams. Well, we already have the conversion factor for copper to grams, and our other conversion factor will be Avogadro's number. So let's work this out. What is the mass in grams of 1 copper atom? So it's 1 copper atom. And I have to add, often students don't know where to start. That is normal. Please don't say, I can't do this, because I know that you can. So if I have atoms on the top, I want to have atoms on the bottom. And I'll put Avogadro's number there. 6.02 times 10 to the 23rd copper atoms. Again, it's just the number in front of copper atoms. And I know that is 1 mole of copper atoms. So if they're asking me now for mass and I have moles, what I will do is use that top conversion factor. I'll say 1 mole of copper atoms is 63.55 grams of copper. And I will come up with the answer 1.055 times 10 to the minus 22 grams per copper atom. So you also get your units when you do this sort of thing. So it really does work out. And since we had only one significant figure to start with, we can only have one significant figure as our answer. 2 problems down, 4 to go. What's the next one? It says, how many atoms of copper are there in 3 grams of copper? Well, we've already written down our conversion factors. So if I have 3 grams and I know that 1 mole of copper weighs 63.55 grams of copper, I'm almost there, because I know that 1 mole of copper atoms, what does it contain? 6.02 times 10 to the 23rd copper atoms. And that will give us an answer of 2.84 times 10 to the 22nd, and it will be copper atoms. And what I have is 1 significant figure and 1 significant figure. So that turns up to be 3 times 10 to the 22nd copper atoms. This is one of the reasons I went with Alex. People would do the problems in the homework and it just did not make any sense. Alex will force you to do more than one problem. But as you do more than one problem, you're going to get better at it. You're going to get frustrated. You're going to get mad at me, but you're also going to get better at it. Okay? So that's enough with copper. What we want to do is move on to ethanol, C2H6O. You don't need to know what the structure is or even the material, because essentially you only have to have a molecular weight. So let's start by doing that. Let's say that when we have this 1 mole of C2H6O, we figured out the molecular weight as 46.04 grams of C2H6O. The other conversion factor we need is we need to know that 1 mole of C2H6O, it contains 6 moles of hydrogen. When I look at the formula, 1 mole, you see that number 6 there. Again, I've worked with many students. I'm trying to point out things that students have struggled with in the past. So now let's solve the problem, okay? 2.5 times grams of C2H6O. We're going to use our conversion factors. We'll say that 1 mole of C2H6O, it weighs 46.04 grams of C2H6O. Then we're going to use the next conversion factor and say there are 6 moles of hydrogen for every mole of C2H6O. And then we're going to put in Avogadro's number, because a mole of hydrogen has 6.02 times 10 to the 23rd hydrogen atoms. Here's where we say you really need to keep a notebook. As you can see, I'm having a hard time squeezing things in. I normally write this on an enormous blackboard. It is actually very enjoyable. So I'll just say keep a notebook so that you can share with us what you've done and where you might be struggling. Mathematically, 1.87 times 10 to the 23rd hydrogen atoms. And since we had 2 significant figures, we need 2 significant figures for our answer. All right, this was a challenging one. Do it step by step by step. And I'll just say that when you're learning something new, you may not be able to do all the steps at the first sitting. It may take more than one sitting. 2 more problems, okay? One of them is moles to ions, the other is ions to mass. So this wants the number of PO43 minus ions in magnesium phosphate. And you can see that in the formula, there are 2 phosphate ions. So that's where we're going to start. We're going to say we have 2.6 times 10 to the minus 3, and I'm going to put the labels. Moles of Mg3PO42. And then I'm going to say, for a mole of Mg3PO42, we have 2 moles of PO43 minus. Then it's just a matter of Avogadro's number, because a mole of PO43 minus has 6.02 times 10 to the 23rd ions of PO43 minus. Now, I'm not going to make light of this, and I guess even though this is online, I have to be honest. You may struggle. I struggled. How do you think I earned my C? Then how do you think I got a PhD? Those are really good questions. It turns out to be 3.1 times 10 to the 21st PO43 minus ions. 2 significant figures coming in, 2 significant figures coming out. Again, challenging. That's what these are. All right. So this had to do with magnesium phosphate. The last one has to do with calcium phosphate. I'm going to write the math down, and as you look at the math, see if you can follow the labels. Now, normally in class, what I do is I do labels on the board. I leave out all the numbers, and I just put all the labels. Can't quite do this online. So what I'll do is I'll take 0.836 moles of calcium 2 plus, and what I will do is I'll look at the formula, and I'll see there are 3 moles of calcium 2 plus for every mole of Ca3PO42. Okay, that's pretty good, isn't it? Then I would have found the molecular weight. I would have said 310.2 grams of Ca3PO42 for every mole of Ca3PO42. And that will give us 86.4 grams of Ca3PO42. So please practice. You may get frustrated. Well, I know many of you are going to be frustrated. I would be lying if I didn't say that. Take some paper and pencil, your iPad and an Apple Pencil. Please just write it down, sit back and think about it. Maybe take some time off, go for a run, watch a movie, talk to a friend, and then come back to it. Finally, on the last page, what we have are a question, a midterm question. And I hope that those 6 examples, after you've walked away from them and thought about them, you can attack this problem. It wants to know how many nitrogen atoms there are in chromium-3 nitrate. So you see there's nitrogen, you see there's the number 3, you see it's given in milligrams. So what you need to do is turn it into grams, figure out the molecular weight, use Avogadro's number. I will let you try this on your own. If you're flying through this, you're done. If you're struggling, do a little bit at a time, because you cannot cram this material. As we hit chapter 3, it's kind of like where there is a wall, and I'd like to help you break through that wall.